Good morning, everyone. This is Mayank here, your student success mentor. And we have Professor R. Chandrashekar with us. And without any wasting time, let's move forward with it. Over to you, Professor.
Okay. Okay. Good morning, everyone. Thank you. So I'll kind of take it up from here. Am I audible? Good. Okay. So welcome back again for this live session, Hangout session. It looks like it might be a relatively short session. I have not received too many queries, so let me go through the questions that have been received. So broadly, I have received a few questions on R and SQL. So I will kind of take them up. Okay, so let me start by taking up the SQL questions, because that is that will contain more of a giving some examples. It might take some time to build up the examples. So the first question that I am seeing here is somebody wants to know more about query optimization in SQL. Okay, so let me quickly summarize where does SQL fit into the analytics picture, and because we have to make sure that we are not carried away or even overwhelmed with the importance of different technologies in the context of the overall objective that we want to achieve, which is analytics, right? So the role that SQL and relational databases, right? So technically speaking, they are colloquially they are referred to as SQL databases, but technically they are actually relational databases. Okay, so if you recall, in an analytics context, so we would generally be working with data which we receive from multiple data sources. Okay, and one of the most likely common data sources that we might encounter is a relational database. Why relational database? Because that is one of the most widely used technologies for day-to-day transactional systems, right? So if you look at any of the traditional, you look at a banking system, or even the modern retail systems, most of them invariably will have some kind of a relational data stored at the back end. Okay, so what it means is many of these relational databases end up being a very big source of data for our analytics purpose, right? So from that perspective, we generally link to a relational database and try to extract the data into our analytics environment for analysis, right? So for our analysis purpose, we are by default going to choose the R programming environment as the environment for our analytics. So in this context, a relational database ends up being yet another data source for us. And we have to keep in mind, we have to treat it only as a data source. Okay, what it means is we probably do not have to be too overwhelmed with all the functionalities and features offered by SQL or by relational databases, for example, right? So what it means is relational database design and implementation can get quite complicated and might involve a fair bit of programming. Okay, so in a typical relational database, you have many players there, right? So we have the database designers who decide, what are the tables, what are the keys, and so on. Then we have the database programmers who actually build applications on top of the databases that are there. And then we have a very important person, which is the database administrator. Okay, database administrator is the person who manages a database, a relational database. So we have a relational database DBA, database administrator, who is responsible not for the data as such, or not for the applications as such, or not even to the logical design of your database, right? So that DBA is responsible for managing the security of your database, managing the performance of your database, and so on, right? So the reason why I'm giving all this context is, yes, it is it is good to have the curiosity to say, what is it, how is the performance of a relational database managed, but be aware that it is okay if you are not an expert in SQL database performance tuning. Okay, so having said that, it's a very good question, and let me try to answer within the context of what you have already seen in relational databases so far. Right, in this particular program, you have seen enough of relational databases that tells you how to design the database using tables, how to access the data that is present in that database using SQL queries. Right, so these are the two primary touch points that is expected as far as this particular course is concerned. So from a performance management perspective, so there is generally we talk about a 3-layer architecture for a relational database. We talk about the external layer where the applications are all running. Then we talk about the logical layer where designers are operating. And there is a layer underneath it which is called the physical database design. Okay, large amount of SQL or relational database performance management is handled at the physical database layer. Every product has got many different features to help optimize the performance of the relational database. Okay, specifically, since the question is about how do you optimize SQL, and the most common operation for SQL is the select operation. Okay, the select operation of SQL is optimized primarily using indices at the physical database layer. Okay, the reason I keep stressing on the distinction between logical database layer and physical database layer is from an application perspective, most of the times we are dealing with the logical database layer. It is the DBA, the database administrator, who worries about making sure your select statements are running fast enough. And to make your select statements run fast enough, so one of the constructs that is used in a relational database is called an index. Okay, index is a very simple data structure. You can think of it like a table of contents in a book, or the index entries at the back of the book. Okay, so in the absence of the table of contents in the book or in the index at the back of the book, if you are looking for something specific in a book, the way you will have to turn across each of the pages to get to the data that you are interested in, a relational database also might end up doing the same thing. Correct? Suppose I say I'm having a banking database and I'm saying select account balance from the account table where account number is 375. Right? In the absence of the table of contents in the front or on the index page at the back, what I will have to do is I will have to go through every row. When I say the relational database system, the runtime system has to look at each record and say, is this account number 375? No, discard it. Is this account number 375? No, discard it. Is this account number 375? Ah, this is it. So I'll stop. So what happens is, in the worst case, I might end up looking at all the, I don't know, I mean, there might be some 1 lakh customers in my 1 lakh accounts in my account table. So I might end up looking at all the 1 lakh rows, and as luck would have it, the row I'm looking for must be the 1 lakh, the last row. So there's so much of effort that is spent, so it is most likely extremely slow and inefficient. So what I do is, so I tell the database administrator that, look, this is the kind of SQL select queries I'm running in my system. Can you please create indices which will make this access faster, right? Then the DBA will look at the kind of queries that you have written, and they will create appropriate indices to make it faster. In this particular case, as a DBA, what I would do is I'll create an index on your account number, right? So what will happen? The account number, it is almost like an index, like the way the index at the back of the book is ordered in alphabetical order. So the one that I want, I can quickly zoom into the exact entry that I am looking for, right? So I will sort it in account number order. So I will quickly get into the 375 number that I am looking for, and then it will say, okay, 375 record is present in disk location, this particular address. Then the DBMS, without looking at each record, it will directly hit upon the exact record that you're looking for. So immediately all the effort that I wasted is recovered, and there is absolutely no time spent. Almost instantaneously I'll be able to find the record that I want. Okay, now so which means it is primarily the responsibility of the DBA. Of course, the DBA will need inputs from you. So generally what we would do is, before heavy duty, regular or production use of SQL queries, we have a meeting with the DBA and show the DBA all the queries that your application will be using. And then the DBA will create enough constructs at the physical database layer to make sure that the database access for you is fast enough. Okay, and if your question is no, when I am writing my own SQL, should I be worried about certain types of queries? Does it matter in terms of the overall performance? Today, the query optimizers that are there in relational database management systems are very sophisticated. Okay, so when I say they are very sophisticated, which means they are resilient to a bit of bad programming, right? For example, I can for some of the SQL statements, I can have a choice between writing it as a nested query versus writing it as a join statement. Okay. In general, a DBMS query optimizer might figure it out, and if you write it in the form of a nested select, it might automatically transform into a join. Okay. Like that, there are many things that you could, for example, the order in which you write the where clause, right? In the olden days, it definitely used to matter, the order in which you present the where clause conditions, right? In general, what we say is the most selective condition should come first. In other words, the condition which is going to reduce my result set quickly to a very short amount, right? Take the customer table, for example. In the customer table, suppose I have the city column, I have the account type column, and I have the gender column, right? So I want to retrieve all the male customers of savings account in the city of Bangalore. Okay, all accounts, right? Savings accounts in the city of Bangalore who are male. Okay, so there are three clauses in my where clause. There are three conditions in my where clause, right? So I will say where gender equal to M and city equal to Bangalore and account type equal to savings. Okay, so logically speaking, the order in which I write this AND clause should not matter. Okay, but in the earlier database management systems, it was considered to be a bad idea to put the first condition as where gender equal to M. Okay, assuming there are in terms of male-female ratio, it is half and half, right? By running the first condition first, the gender equal to male first, all I managed to do was I managed to reduce my data set of 1 lakh records into 50,000 records, which means for the subsequent conditions wherein I will say where account type savings equal to savings, that one still has to operate on this 50,000 rows. Okay. On the other hand, suppose it turns out that in the city of Bangalore, out of those 1 lakh records, I have only 10,000 records belongs to Bangalore. Then I would rather apply that filter condition first, right? So I will say where city equal to Bangalore. Immediately that 1 lakh records gets reduced to 10,000 records. So the subsequent conditions now have to operate on a smaller data set. Okay, so this is one example where a badly written query could result in a slower performance, whereas if it is modified or transformed differently, it might give better performance. Okay, but in both cases, we are saying there is absolutely no question that the result has to be exactly the same. So we are not compromising on the output. but know whether something is faster or slower. Having said all of this, many modern operating database management systems have the capability to do the transformation that we just talked about. As a programmer, if you had written that where gender equal to M or F as the first condition, it automatically figures out, using what is known as a selectivity statistic of that particular column, and then it will say, no, I'm not going to apply this first. Let me look at a better column which has got a higher selectivity. So the bottom line is that as a developer, definitely as an analytics person, you don't have to worry about writing SQL queries from a performance, worrying about the performance aspect of it. This is not to say that you will never face performance problems. If you do face performance problems, my suggestion is you take your list of SQL statements and sit with the DBA, run it by them so that they can take the necessary steps to make your query faster. Okay, so that is on the query optimization in SQL, essentially, which is something that the DBA and the DBMS system manages it. Is there any performance impact in retrieving information if SQL tables do not have primary keys? I would say yes. There would be a performance impact if in your where clause you are using those attributes which can serve as primary keys. I just now used an example in the account table. If account ID is the primary key, and in my where clause I'm saying where account ID equal to 375, then it's a bad idea, and your performance will definitely be impacted. You know why? Because what happens is when you declare something as a primary key, an index is automatically created for that particular primary key. Okay, so yes, the absence of primary keys does impact the data retrieval from a relational database if your where clause contains those primary keys. Okay, and even otherwise, it's generally a good idea to have primary keys for your tables. I'm not clear on the joins. Okay, can you please explain 2 table and 3 table joins? Let me see if I can load up some presentations. I'm sure I have shared these presentations with you. Okay, so let me try to share this screen. Just give me a minute, please. Okay, I hope everybody is able to see this screen, which has got an example. Okay, so please give me a shout out if you're not able to see the screen. All right, so let me give you, walk you through a simple example of a join. Okay, so there are, in this particular example, there are 2 tables called the client and viewing. Okay, I think this is some example on real estate. Okay, so there are so the attributes are, there is a client number, first name, last name, property number, and comments. Okay, so what is the client table C contains all the information about the clients, and viewing is another table which contains the comments of the clients on those different properties. Okay, so this is a 2 table query. So what we are saying is joins play a role whenever you want to display related information from 2 tables. Okay, so if the information is present in only one table, then there is no need for joins in general. Okay, there are some exceptions to that. Okay, but in general, if the data that you want to retrieve pertains to information only from a single table, you do not need joins. If you want to retrieve data where some part of the data is present in one table and another part of the data is present in another table, then you have to use joins. Okay, if I take the usual simple example of customers and branch. Okay, if in a single query you want to display both the information about the customer and their branch details, then you have to use join. In a single query, if you want to display the information about the account and all the transactions that they have done, then you have to do a join, assuming account information is present only in the account table and all the transactions information is present only in the transactions table. Got it? So that is the first thing that you have to remember all the time. In a relational database, it may so happen that the information is now scattered across more than one table. Okay, so let me take this same information. Suppose we have the customer table, we have the account table, and we have the customer account, yeah, sure, and the branch table, right? So if I wanted to show a report, because suppose there can be joint holders, so every account can be associated with more than one customer. So if I want to link information, customer information, account information, branch information, then it becomes what is known as a three-way join. Okay, let us come back to this particular example. Okay, as you can see in the first line, in the select clause, I can include all the attributes from more than one table. Okay, so in this particular example, I am displaying client name, F name, and L name from the first attribute, from the first table. So property number and comments are coming from the second table. Okay, so I want to know what are the comments given by each client when they looked at the property, right? So whenever you want to combine information from two or more tables, what you need is a link field, right? There has to be some commonality, common attribute between the two tables, which is also called as the join condition. Okay, in this particular example, the join condition happens to be specified in the where clause, right? In the where clause, when I say c.client number equal to v.client number, this is called the join clause. Okay, so I'm saying this is the link field, which means I am going to link the information, the client table information with the viewing table information using this common attribute called client number. Okay, so now what is the C and V? C and V is nothing but a alias for the table called client. Alias is nothing but a short name. Okay, so C is a short name for client, V is the short name for viewing. Okay, so this is a simple two-way join. So there are three parts to it. So how does the join? In my select clause, I am free to include names of attributes from two or more tables. That is number one. In the from clause, I should specify all the tables that I want to link or join. Right? In the where clause, I specify the join condition. Okay, let me repeat the three parts. In the select clause, you are free to specify attribute names from more than one table. Okay, in the from clause, you have to specify what those tables are. And then finally, in the where clause, you have to specify if there are two or more tables, you have to specify what the join condition is. Okay, so this is, let me see if I can give you one more example. Okay, so this is also called the equi-join. So as you can see, so here the client number is essentially my join clause. So client number 56 has given this particular feedback, right? So there some comments are there, some comments are not there. So the thing to note here is the most important field here, the comment, is coming from the view table, and the rest of the attributes, in fact, the property number and the comment is coming from the view table, and the client number, F name and L name, is coming from the client table. So we are displaying information from more than one table, right? So the select clause, so we mentioned that we want some attributes from the first table and some attributes from the second table, and then we have specified the join condition and then table names. Okay, so this is another syntax for the same join clause. From client C, join viewing on. So here the two tables are specified in the from clause, and following the on clause, what you have is the join condition. This is an alternative syntax. Okay, so don't worry about alternative syntax. If you understand the basic concept, you can either use the previous syntax, or the most other common syntax is the first one here, from client C, join viewing V on C.client number and V.client. Okay, so, and then sorting and so on. This is nothing. Three table join. So now I'm saying for each branch, list the staff who manage properties, including city in which the branch is located and the properties they manage. Okay. Now you can see in my select clause, I am displaying the branch number and the branch city from the branch table, staff number from the staff table, F name, L name from the staff table, and the property number from the property for rent table. Go back to what I said earlier. In my select clause, I'm free to display the attributes from more than one table. So in this particular example, I'm displaying attributes from 3 tables. That is why in my from clause, I have to list 3 tables: branch B, staff S, and property for rent P. Right? B, S, and P are nothing but short names or alias. Okay, makes it easier to type. It's got no other function. Okay, and as I said, in the where clause, I have to specify the link, right? The join condition. So I have 2 join conditions: B dot branch number equal to S dot branch number, and S dot staff number equal to P dot staff number. Okay, now this can be a bit tricky. How do you arrive at the join conditions? In general, if there are n tables in my from clause, the number of join condition equal to n minus 1. Okay, if there are n tables in my from clause, the number of join condition is n minus 1. In the previous example, in my from clause, I had 2 tables. I have the client and then the viewing, right? So I had 1 join condition. In this example, there are 3 tables: branch, staff, and property, which means that I need to have 2, right? 3 minus 1 equal to 2 join conditions. In fact, in my from clause, if there is only 1 table, 1 minus 1 is 0, which means I don't need to have any join condition, right? So that is one part, right? How many join conditions should be there in a whenever there are in a select statement? The number of join conditions is equal to n minus 1, where n is the number of tables included in the from clause. Okay, now all you have to do, keep in mind when you have these 3 tables, is that the join clause between any 2 pairs of tables. In this particular thing, I have the join clause which is establishing between branch and staff and property. Okay, I might as well have, if possible, I could have done a join between branch and staff and branch and property as well, if there is a common attribute between them. Okay, so in this particular example, it so happens that the common attribute is there between branch and staff, and there is a common attribute between staff and property. Okay, the common attribute is branch number between branch and staff, and the common attribute is staff number between staff and property. Okay, what this also means is that If there are no common attributes between two tables, you cannot include them in the join. Just keep that in mind. You cannot randomly, I don't know. So suppose there is a standalone table called what shall I say? Standalone table called builder. Okay, which contains only the builder name and the builder address. Okay, so if that is a standalone table, I cannot simply do a join between the branch table and the builder table unless there is a common attribute which is linking the branch with the builder. Okay, either you should put the builder number in the branch table or branch number in the builder table. Got it? All right. So that is essentially the join condition. Okay. So this is example of a 3-table join and so on, right? So I think you must already be having access to these slides, I hope. Okay, so let me stop the sharing. Okay, so that takes care of the SQL join question. I think that's pretty much it. Okay. Of course, there is a possibility that you probably have some problem with the inner join versus outer join. So let me give you a quick. Let me see if there are slides with outer join example as well. Okay, so let me take this example for the outer join. Okay, so this is okay, so let us just take this example. Okay, there are two tables called branch 1 and property for rent 1. Okay, so in the first table, I have two attributes called branch number and city. In the second one, I have property number and city. Okay, now if you do a simple join between these two, okay, first of all, we have to ask, can I do a join between these two tables, right? So the answer to that question comes from, you can do a join between these two tables if there is a link attribute or a common attribute between the two tables based on which you can do the join. Are we satisfying this particular condition? If you look at this particular example, yes, there is a city column which is common between these two tables. What it means is I can do a join. Okay, very good. So that is my first thing. Now, if I actually do a join, right, how many rows will be there in the output of this particular join? Can you take a moment to mentally figure out? In fact, if you have understood joins, you should be able to answer this question. If I do a join between branch 1 and property for rent table, how many rows will be there in the output? Okay, I can't hear what your answer was. If your answer is 1, you are right. Right? So it is likely to contain exactly 1 row. Okay. Okay, I didn't. Oh, sorry, my mistake. So there are 2 rows. One, the 2 values that are common between the 2 tables, the Glasgow and London. Glasgow and London is appearing. So that is why if I do a normal join, I will get 2 rows. Okay. So if you had guessed that it is 2, your answer is right. So that is the result of a normal join. Okay. So normally these regular joins, what they will do is, if there is no matching row in the other table for a given value, in this particular case, that value happens to be Bristol. Okay. Bristol in branch is not appearing in the output. Similarly, Aberdeen in the property for rent is also not appearing in the output, right? So those two rows are removed, eliminated. Okay, so many times it is okay, right? So it is okay from an information perspective, because I'm only interested in finding out where all the properties for all the branches. Okay, but this particular output does not give me the information that in that other Aberdeen, Bristol, for example, the fact that in Bristol there are no properties. Okay, that information is not visible in this particular output, isn't it? The fact that there are no properties in Bristol is not visible here. Similarly, the fact that there are no branches in Aberdeen is also not visible here. That is because there are no matching rows in the branch table, or there are no matching rows in the property table. In this situation, we would want to do what is known as an outer join. Okay, so okay, let me show you the output straight away. Right, so this is the output of the outer join. So now you can see Bristol, B004 Bristol has got a branch, but then no, we have already seen that there is no property in Bristol. Okay, I hope you remember that there is no property in Bristol. So let us quickly go back and check that. Right, if you see the property table, there is nothing where PCT is Bristol, right? So when I come back here, right, in Bristol there is no property. So when you do an outer join, it will indicate that there is no property in Bristol by putting null values against those attributes which come from the table where there is no matching row. In this particular case, it is the property table which does not have a matching row. So I include those null values there, and very clearly from a user perspective, this is much more informative to me than the previous output, which was quiet with respect to Bristol, right? Then I really don't come to know why is it that Bristol is not showing up. So this one very clearly is saying that Bristol doesn't have any properties. Okay, so let us look at so this particular thing is called a left join. Why is it called a left join? Because here every row from the left table will show up. What is the left table here? It is the branch table. The right table is the property table. So every row in the left table will appear. If there is no matching row found in the corresponding right table, I will put null values for those attributes, but it is guaranteed that every row from the left table will appear in the output. Okay, so Glasgow, Bristol, and London shows up. Okay, so let me show you the syntax for that. The syntax is very similar to the normal join. So in the select clause, you can choose whatever attributes you want. In this particular case, when I say b dot star, I'm saying all attributes from the B table. P dot star, all the attributes from the P table. From branch B, left join property for rent, right? So this is where the left and right significance comes in, right? So here the left table happens to be branch, and the right table happens to be the property for rent. Okay, so left and right. Yeah, so that is the syntax of it. Okay, so this is called the left join. So what I'm calling as the normal join all the way is technically referred to as the inner join, and this is the outer join. Specifically, this is the left outer join. Okay, so when I look at this particular output, what you should remember is one particular row from the property table is still missing. Which one is that? That is the Aberdeen, right? So if I want to see Aberdeen in my output, what I have to do is I have to do the right join. Okay, now you can see that PA14 Aberdeen shows up in my output, but there is no corresponding branch. So what it will do is, for all those attributes of the left table, now I will show null values. Okay, so this is called a right join, the right outer join, because every row from the right hand side table, which is property in this particular case, will show up in the output. And if there are no matching rows in the left hand side, it will just pad them up with null values. Okay, this is called the right outer join. Okay, as you might have guessed, right outer join is kind of redundant. I could have obtained the same output by using left outer join, wherein I could have put property on the left hand side table, right, instead of putting it as the right hand side. But that's okay. So the syntax for the right outer join is like this. So you can see that branch continues to be mentioned on the left hand side. Property for rent is mentioned on the right hand side. And the keyword right join indicates that I need property for rent, all the rows from the property for rent, and you can pad the branch if there is no matching row. Okay, and the requirements of having a join clause is same. It still exists for similar. It's just similar to the inner join. Okay, for inner join also you needed all these join conditions. All those rules still hold, which means in the select clause you can include attributes from multiple tables. In the from clause you must mention that all the table names from which you have retrieved the attributes, and you should have n-1 join conditions in your in your query. Okay, and depending upon whether you want an inner join or an outer join, you can simply use the word inner join, or you can use left join or right join for outer join. Okay, good. So that is about outer join as well. Hopefully that kind of clarified the join part of it. Once again, this is just a concept of join. Be sure to review this in the usage of merge in R. Okay, you should remember that join is referred to as merge in R. So all the examples, exercises, case studies that you have done before, you must have already received the solutions for that. So make sure to play around with it and see the output of merge. Okay, so left merge, right merge is the terminology that is used here. Similarly, you will find the concept of joins in Tableau as well. If you remember, in Tableau they show it using those circles, the Venn diagrams, which is essentially indicating. So when you try to load two data sets, for example, if you are trying to add two worksheets from a workbook in Tableau into the data space, it will automatically try to help you, saying that, okay, it looks like you're trying to do a join, and please tell whether you want an inner join or left join or a right join. Okay, so this concept is very important. Make sure you understand it well. Okay. Okay, so that is about joins in R in SQL. Request for more examples and references to differentiate primary key and foreign key as a concept. It is still not clear. Okay. All right. See, primary key is something that is unique in a given table. Okay. So if I take the customer information, within the customer information, customer ID is something that is expected to be unique. So that is called a primary key. I don't think there is any confusion about what a primary key is. But when I bring to the mix this foreign key, maybe that's when the confusion sets in. Okay. See, foreign key, you think of it like a simple link. Okay. It is a simple link into another table which contains more details about that. So in my customer table, I have a column called branch ID. Okay. Now, all details about this particular branch is not present in the customer table, right? So that is present in another table, which is called branch table. Okay. So what I say is, in my customer table, I put this branch ID and then say, you know what? This branch ID is actually a primary key of some other table, not the customer table. Okay. If it is a primary key of some other table, then I call this as foreign key in the table where I am using it as a link field. So in this example, in the customer table, only branch ID is here. So the branch ID is a link field wherein no further details about the branch is present here. Okay, so I link it to a primary key of the branch table. Within the branch table, branch ID is a key, primary key, because branch ID I don't want, I generally do not have, I should not have duplicate values for the branch ID, B001, B002, and so on. Okay, so don't, so when I, maybe the source for confusion is that the theoretical technical definition of a foreign key is that foreign key is also a primary key. But if you don't complete that sentence by saying that, yes, foreign key is a primary key of another table. In this particular case, in the customer table, branch ID is a foreign key, and is also a primary key of the branch table, right? So a easier way to think about it is, if it is confusing, yeah, I mean, I do agree, right? Generally, when we use the term called key, we expect it to be unique. Whereas in the customer table, we find that there are many customers belonging to the same branch. Where is the uniqueness? So it's not a key. So that's my, it might be confusing. If you want, you can mentally think of it like a link field. Don't even call it as a foreign key. You just think of it like a link field, right? So that is a foreign key. So this particular foreign key happens to be the primary key of some other table. Okay, so that's why, so which means any primary key can act as a foreign key in some other table. Okay, so that's essentially the difference, which means a foreign key need not satisfy all the requirements of a primary key. One of the most fundamental thing about a primary key is that in that particular table, the values of that cannot repeat. Right? If I'm using customer ID C07, C07 cannot appear more than once in that particular customer table. But in a branch ID is a foreign key. If there is a branch ID B01 that is appearing once, it can appear twice, because foreign key can repeat. Okay, so that is essentially the fundamental difference between a primary key and a foreign key. And I can understand the source of confusion will go away when you say that foreign key is also a primary key, which happens to be some other table of a primary key of some other table. Okay, what it also means is that when it is a primary key of some other table, why do we have to say this, right? Why do you have to say that this is a foreign key and all that stuff? Why don't I just be quiet and say, okay, this is branch ID, and if you want more details about this particular branch, please go to that table. So what do I gain by declaring this particular branch ID in the customer table as a foreign key? What do I gain? What I gain is what is known as referential integrity, which means I guarantee, when I say I, the DBM, the system guarantees that no invalid branch IDs are used in my customer table. Okay, so if I try to insert a new customer with branch ID, say 3000, and in my branch table, there is no branch ID called 3000. They have not even constructed it, right? So if I permit branch ID 3000 to be used in my customer table, I have data integrity problem. Okay, because I am specifying I'm using a branch ID which is invalid. Okay, one way to do that is, in my program, I'll check whether this is a valid branch ID or invalid branch ID. But data integrity is generally considered to be so important to a relational database that they have built it into the relational database system itself. So when you declare it as a foreign key, no value, I mean, other than those values which are appearing in the branch table, is permitted here. Okay, so the same argument you can carry on between any pairs of tables which have a foreign key relationship. right? Can you think of another pair of tables where there is a foreign key relationship in the banking domain itself, right? Account table and transaction table, right? So what is likely to be the foreign key in which table? In this example, in the transaction table, the primary key would be transaction ID and the foreign key would be account ID. Okay, right? Essentially, it says that this particular transaction happened on this particular account ID, right? So by declaring transactions account ID as a foreign key, what I am ensuring is that transactions do not happen on invalid accounts, isn't it? The account ID that I'm putting must be one of those existing accounts. Okay. Good. I hope that clarifies on foreign keys. Okay, so let me kind of slowly move on to some R questions now. Okay, so there are some questions on the apply family of functions. So let me begin with that. So I need to pull in my R console. And I'll share my R console now. Okay. Okay, so let me load some data sets. I'm loading the Bollywood data set, which I might use for some examples here. Okay, so let me, there was one question about single versus double square brackets. Single versus double square brackets play a role in, especially double square brackets come into the picture when you're working with lists, okay? So to do that, let me create 3 vectors, okay? And then I'll create a list out of it, okay? So let me, yeah, so my list is a list. So v1 square bracket 1 will retrieve the first element of the first list. So that's a general standard use of the square brackets. Now let us try to use a single square bracket on a list. Okay, so let me just show you the data itself. There are, this is a list which is comprised of 3 vectors. Hopefully you remember the difference between a vector and a list, right? So one of the fundamental difference between a vector and a list is that a vector can contain is homogeneous in nature, which means the data type of all the vector elements must be the same. Okay, whereas list is a heterogeneous data structure, which means I can have a list. In this particular example, I happen to have created a list with 3 separate vectors. It could have been, in fact, the 3 vectors are all numeric vectors, but this need not be the case, right? V1 might no, could have been a vector of numbers, V2 could have been a vector of strings, and V3 could have been a vector of Boolean values. It doesn't matter. In fact, it can be virtually anything, right? In fact, I can have a list wherein each member is a data frame. Okay, so it's a very, very powerful generic data set. Okay. Okay. So having said that, so this is a very simple example wherein my list happens to be 3 vectors. Again, I repeat. So this need not have been 3 vectors. The first one could have been a vector. Second one could have been a data frame. It would still work. Whereas if it's a vector, it all has to be the same. The two, it has to be a primitive data type like a string or a boolean or a factor or something like that. Okay, good. So when I have these, so what it shows is that these are my 3 vectors. So for this is my first vector 1 2 3, second vector 4 5, and the third vector 6 7 8. If I try to access my list square brackets 1, it will return the first vector 1 2 3. What will happen if I return it with a single square bracket? Even there it is returning 1 2 3. But what you should notice is that if you use a single bracket on a list, it will return another list. Okay, so let me show that to you. So suppose I say class of my list, the list, whereas class of my list square brackets 1 is numeric vector. Okay, so that is essentially the fundamental difference between a list and between square brackets and a vector. Okay, so this is an indication that it's a vector. All right, so let us see. So I think that clarifies the difference between double square brackets and the single square brackets. Most of the times when you are accessing elements of a list, you would want to use double square brackets. Okay, because only when you want to another list out of that same, creating a sub list, for example, that is when you should be using a single list. I don't see why I would want to use a square brackets. Most of the times my usage would be double square brackets, because if this happens to be a data frame, I would want the data frame as it is. I don't want the data frame to be wrapped inside another list. That is essentially the difference between a single list and a double list. Okay, so let us quickly talk about the apply family of functions. Okay, so there are many different. Okay, one of the fundamental strengths of the strengths and fundamental differences between R and a regular imperative programming language like C++ and Java is that many of the is the support for vectorized operations, isn't it? So when I talk about when I say vectorized operations, there are many functions which take which work with whole entire vectors. Okay, what it means is that I don't have to write iterative programs. I don't have to write programs with for loop for working with vectors, which is a big strength of the R programming environment. So that is why you should become extremely comfortable working with vectorized operations, vectorized access to elements of a data frame, right? So how do you extract only NA values from from a vector without using the loop operations, isn't it? So those are all the techniques that you have to learn when you are working with R. Okay, so internally, many of those vectorized operations are implemented by R using more or less something similar to this apply family of functions. Okay, so these apply family of functions are generally very powerful, which means if you have a collection of data, okay, so if you have a collection of data and then you want to apply a specific you want to apply some operation on that without writing a loop. Okay, I'll give you some cool examples on the Bollywood data set later on, but that is the whole idea, right? So the two things is that R is trying to give the programmers something very powerful which it internally already uses quite a bit. Okay, so so that is something, so which is essentially a powerful tool for vectorized operations. Okay, so let me come out of my screen share. So I'm going to illustrate a couple of general usage of apply family of functions, because not all of it, there are so many variations, not all of it is applicable everywhere. Just to give you a glimpse of the apply, I will just illustrate it with just talk about lapply and sapply. Okay, so lapply is a function wherein which you will apply when you want to implement or invoke a function for every element of a list. Okay, so this is how you interpret it, right? Func is a general purpose function. Okay, it is expected to take one argument. Okay, now when I call a function in general, I pass it the set of values, right? So okay, so we already have a list, right? So my list. So there are 3 elements as part of this my list. Okay, so let us do a simple lapply on my list, and then I want to invoke this sum. Okay, now what kind of a function is sum? Sum is a function. Okay, so let me, even before using this particular lapply, let me do a simple sum, right? So sum, how do you call? So you say sum and then v1. It will return the sum, right? So v1 happens to be 1, 2, 3. 1 plus 2 plus 3 is 6. So sum is a function which takes one argument. Okay, so let me do the same thing with lapply my list sum. Now what is the interpretation of this one? So what we are saying is, now we already know that my list is a list which contains 3 elements. What are those 3 elements? 3 elements are 3 different vectors. Okay, now in lapply I am passing this function as an argument itself. Remember, I'm not calling the function here. So what lapply will do is, it now sum doesn't work without any arguments. I have to pass an argument, right? If I simply say sum, I don't know what it will say. It will just say nothing, right? In fact, I was even expecting an error saying that there is nothing for me to add. Okay, so when I'm saying lapply my list and then sum, so sum will expect an argument, right? In general, sum will expect an argument which is a vector. Okay, now where is the vector coming from? What lapply will do is, it will look at the list that you are given. It will invoke this particular function on each member of this list. Okay, so in each member of this list, so there are 3 lists. So when I invoke this particular thing, it is returning the values 6, 9, and 21. Okay, which happens to be the sum of all the elements of that particular list. Okay, so when it is passing these elements, of these, whether it is, you can see that when the output is displayed using double square brackets, it is displayed in the form of the output is like a list. Okay, the same thing if I do it as an sapply, it will simply give it to you in the form of a vector. Again, most of the times the output in the form of a vector, right? The numbers are still the same, 6, 9, and 21, and the output is still the same set of values, but returned in the form of a single vector with 3 elements. Okay, so that is essentially the function of apply. So what the same thing if I had to do using a loop. Suppose I wanted to find out the sum of the invoke this sum function on each of those vectors, I could have written a loop. I could have said that for each member of my list, okay, and then I could have said sum of the element list, right? So instead of doing that, I'm actually, this is a very convenient way of doing this, right? The same thing is, now here I'm applying this something called length. So the length of these elements are 3, 2, and 3. And if I do it like S apply, it is 3, 2, and 3. Same thing. Okay. So that is S apply and L apply. Similarly, there is a much more generic function called the apply function. Apply generally works with matrices. Okay. When in matrices, when you are working with matrices, you want to do some operations for every row or every column, you can use the apply family of function. Okay. Let me give you another example which I kind of cooked up. It sounded interesting to me, and hopefully you will also find it interesting. If you recall the Bollywood data frame, right? So if I look at the movie name, right? So the BDF is my data frame. So the movie column contains all the movie names, right? So Dilwale, whatever, right? So I can even show you more values. Let us do a head BDF dollar. And so Dilwale, Bajirao Mastani, head story 3, etc., etc., right? So suppose I want to create an output. I want to create saying that I want a new variable which says movie name along with the hero name. Okay, the hero name is present in. Okay, so for the first movie, Dilwale, see what is the hero name. So BDF dollar hero, the first one. So SRK. So I want to say the output. I want to create a new column. It says Dilwale with SRK. It's a new column. Okay. So this is how I can do it in the form of a loop. Okay. Okay. So let us just run this. So somebody was also asking, how do I run the whole code instead of running it run by line? I can highlight the code and then press Control Enter. That entire code runs. So if you want to run the entire script, you can do Control A and then press Control Enter. The whole script runs. Okay. In fact, you will also be able to run these scripts on the command line as well. Okay. You can simply say R space the name of the script. It should run. Okay. But then you should remember that the output will be displayed on the console itself rather than inside the RStudio environment. Okay. So what I have done is, let me walk you through this particular loop. For R in 1 to n row BDF. N row gives you the number of rows in this particular data frame. So n row, let us see what is the output of that. 52 rows. So for R in 1 to 52, so this is a simple vector of 1 to 52 numbers. So what do? First, I find out, I just display what is the, this is just for my convenience, and displaying what is the Rth movie name. But more importantly, I am creating a new column called movie with hero, right? So I'm indexing it with this number called R, and I'm simply using the paste function. Paste is nothing but the concatenation function in R. So I'm saying BDF dollar movie R, and then the string called with, and then BDF dollar hero R. Okay, so this is the most the old style, if I can use that term, right? As a programmer, your first instinct, if I had given you an assignment saying that create a new column called movie with hero, wherein you have to concatenate the name of the movie with the name of the hero. If I had given this as an assignment, your intuitive reaction to this would have been to use a for loop for this. Okay, so let us see how you can think of it like a vectorized operation. So what I will do is, first I will create a simple function called movie with hero. Okay, movie with hero is a function which takes two arguments called movie and a hero. and I simply concatenate and return the value. Okay, so let me create this particular function. So I have created this function. I can test it out simply. I'll just invoke it, movie with hero. It takes 2 arguments. I'll say Don, and I'm going to say SRK because I'm an Amitabh fan. So it will say Don with Amitabh, right? So this is my function, but we are not done yet. I have only written my function. So now what I will do is I can invoke my apply function. So this is an example of using apply. Okay, the apply syntax is slightly different. So I'm going to do use the apply function here. What is it? What is the first argument? First argument is the data set on which you want to apply this particular function. So what I'm doing is I am invoking BDF. So what does this return? Let us run this one. Can you guess what this returns? Okay, I'm missing a square bracket. Right, this returns a 2-column output which contains the movie name and the hero, right? Because we are interested in that. Okay, then what I'm saying is, right, so there are 2 ways in which this will work. So what it will do is this apply function works, 2 is for working at each row, and 1 is to apply it for each columns. Here I want to apply this particular movie concatenation for each row, right? So I want to say Aptak Chappan with Nana Patekar, Badlapur with Varun Dhawan, and so on, right? So that is the output. So 1 indicates you apply to every row, and 2 indicates you apply to every column. So I'm saying you apply to every row, and then what is the function? So I'm just saying, so I'm creating a new function called X, which takes, because the argument, right, it invokes this particular function, right? It invokes this particular function on every row, right? So that is why I'm giving 1 here. It takes the 1 row, it will pass it as an argument, right? So when that 1 row comes as an argument into this particular function, I'm taking and the hero name, and then I'm invoking movie with hero. Okay, so this is essentially, so I'm invoking, this is an anonymous function. This is a named function that I had written here. So I'm invoking this particular function on 2 arguments, right? So x1 and x2. Where are x1 and x2 coming from? X1 and x2 is coming from this apply function, wherein I have asked it to invoke this particular function for every row, which is 1. Okay. So what I will do is I will share this particular code with you. I want you to play around with it, right? So what will happen? What will happen if I use an sapply function? What will happen if I use an lapply function on this? Or for that matter, what will happen if I change this 1 to 2? I want you to see the output. Okay, so do play around with it. This is, yeah, it might be a bit tricky, but once you get a hang of it, you can do very cool things with it, and definitely you will it is definitely a sign of our expertise once you have gotten to that particular level. Okay, good. I think that should take care of your apply family of functions. Okay. Generic question saying that how do I become more comfortable with R? Yes, I can understand your question, because if you think that merely doing the Bollywood assignment and the case study, the investment case study, that is good enough for you to gain expertise with R, I think it's a little doubtful. So I'll tell you, right, how I built expertise in Excel. I'm sure all of you are very comfortable or reasonably comfortable with Excel, right? So whenever you you have to do some look at some particular data, right? If you start using the relevant tool all the time, more frequently on a day-to-day basis, you will gain more expertise with that particular tool. Okay, the same thing applies to any tool, right? So all of us are working professionals. You know how it works, right? Even things like PowerPoint. I mean, right? It is one thing to use PowerPoint as a very dumb thing, but if you are making many PowerPoint presentations, you naturally tend to experiment with new features of PowerPoint, right? How do you do animations? How do you make text fly, zoom, and things like that? I think we gain that particular expertise, right? The moment you keep tinkering with it, you'll keep looking at it, and the moment you find some functionality which is of interest to you, immediately you go and try to find out how do I use this, right? If you have been working with PowerPoint and for at least for even more than a year, if you have not been curious to use specific features, then I think you are not uh, making an attempt to gain expertise in that, right? So if you are using PowerPoint and then you say there are this feature called animations, then immediately you should look up, try to find out, try to use it, right? So there is no shortcut to keep on playing with it. Similarly, with R, you should have a shortcut for R Studio somewhere in your desktop. Okay, whether you are using Linux, Mac, or whatever, right? The moment so this is the time where you should not be afraid to step out of your comfort zone. Assuming your comfort zone with Excel is higher than that of R, so many times it is the Excel which is the spoiler. Okay, if you feel like looking at the data rather than resisting the temptation to double click on an Excel file and looking at the data in Excel, I urge you to open up RStudio. Okay, it is just 2 or 3 lines of code to load Excel data into a data frame. That's it. Start from there. Okay, so my thing is, have an RStudio window open all the time, right? Today all of us keep the mail window open all the time, just like you keep the mail window open all the time, or a web browser window open all the time. Have an RStudio window all the time, and trust me, the skills will come naturally to you, right? The quickly looking at a data frame, the values, all that syntax will come flying to you, trust me, right? Just during the initial period, resist the temptation to open up Excel and look at the data in Excel. Just think that R is the only thing at your disposal. Keep thinking R. You'll trust me, you will get that comfort value with respect to R. Okay, hopefully that's more of a general, I would say, a lifestyle change almost from a professional perspective. Please explain about the when to use sort and when to use order function. Yeah. See, this is let me give you a generic answer. There are many questions along these lines, right? So when should I use this versus that? Similarly, there was a question about the difference between class and a type of. Okay, the difference between sort and order. Okay, please remember that R is an open source package and it has evolved over a period of time. Okay, so initially there were certain ways in which things were done, and subsequent releases, as R kept evolving, more and more features got added to R. Okay, so to make things easier to work with. Okay, so I would imagine the order function is slightly older versus sort. Okay, because when your usage of the order function, order actually returns ordering of the index values, okay, of the sorted numbers. It doesn't return you the data frame itself. Okay, you have to return the output of R in a vector notation to retrieve the data frame values in sorted order, right? So I would imagine sort is a much more a better convenience function for doing for retrieving the data values which is already in a sorted order. Okay, so it is so like that there are many convenience functions that are added, and so these convenience functions, some of it are added to R directly, some of it appear in the form of external packages. Okay, so this is almost like a I mean, you can imagine, right? If something has made its way into the R syntax, it must be something which everybody in the R community approved, and then they gave their green signal to say that, okay, can you please make it as part of the core R package itself? Whereas other things, people create more convenience functions for data cleaning, etc., etc. And then, for example, take another. There was a question: how do I deal with missing values? Right. So there is a fundamental function called is.na, which will give you the list of which is a boolean, which returns a boolean value on whether a given value is null or not. So I can easily use that on a data frame to extract rows which contain null values, to eliminate rows which contain null values, and so on. Now there is a convenience function called is.complete. Right? So the complete function returns data frame rows, whereas your is.na doesn't return the data frame rows. Right? So the difference between sort and order is exactly the same. One is better convenience. So if you want finer control, then you use the lower level function. In this particular case, if you right, for example, when should you use the order function, right? Suppose you are not interested in the entire sorted list. Suppose you want to create a rank list, then order is sufficient, right? So the order you can with the order you can assign a rank number, and then from which you want to display only the top 10 values, then order is sufficient. Then definitely I cannot do those kind of things with sort, right? Things like ranking, things like returning the top 10 values, those things are better done using the order function than the sort. Okay, so that is that question. The SQL-df package. While using the SQL-df package, I'm trying to run correlated subqueries using exists clause, but R is not responding. Okay. Please remember that SQL-df is just a help package, which is an external package. By using SQL-df, you are not doing. I mean, see, the specific question is that the exists clause does not seem to be working. Okay. In fact, you should know that exists clause does not work in many relational database systems itself. Okay. So what you should find out is the SQL-df package, which to what extent it supports the SQL language. SQL language itself has undergone many standards revision, right? So please go through the SQL-df package. I did not get a chance to look into that before this particular session. Maybe offline we can look into it. But do take a look at the SQL-df package. I won't be surprised if it doesn't support the full updated SQL standards. Okay. For example, I don't know, you can check whether it supports the notion of an outer join, right? So whether it supports other kinds of table aliases, column aliases, and things like that. But I'm not surprised that it is not working, because exists is similarly, you can look at exists, union, intersect. These are all constructs that are there in the SQL standard, but not all implementations support all of it. Okay, so I don't think there is anything wrong with the query that you have written. When I look at your query where exists, the query is perfectly fine, right? Syntactically. In fact, you can confirm by running a similar query in SQL. Okay, I think the query syntax is perfectly fine. it looks like the SQLDF package itself is not capable of running this particular SQL. Okay, which is where which is where the use of convenience packages and functions always come with constraints. So you are better off trying to learn how to do many things from first principles, right? So now that this does not happen, can you go back and look at how do I use any vector operations or anything like that by on the data frame itself to obtain the results that you are. All right. So the answer to the question, where am I going wrong? I don't think you are going wrong anywhere. Implementation of SQLDF, which I'll try to confirm in the discussion forum later on. So the next question is, R supports functions such as filter, group by, join through packages. R also supports similar functions through SQL queries. Question is, which one is better and faster? Doing it through SQL queries is likely to be slower. Okay, unless the SQL query is running in the relational database itself. If you are using packages like SQLDF and so on, I would think that is definitely likely to be slower. I would suggest that you use native R functions if you are using extensive data manipulation. Okay, I understand that many people who are comfortable with SQL have the temptation. It's almost like the example that I told it, right? You have to step out of your comfort zone, right? Excel, and then, I mean, the same thing you can say about Excel, right? There are so many things I can do with Excel so easily. Why should I even bother with R? Okay, let us remember that, let us try to accept the fact that, you working with R makes things easier, and R is definitely more powerful. So to that extent, try to learn as many things to do as possible using native R functionality. Okay, yeah, so that would be my answer with respect to use of many of those packages that are available. Okay, in fact, I won't be surprised if there is some package out there which will try to run Excel formulas in R. Okay, when you can do that as a fundamental thing in R, just because you are more comfortable with Excel, don't try to create Excel in R. Similarly, I would say, don't try to create or use SQL extensively in R, because try to be comfortable, come out of your comfort zone. R programming language has several packages. Yeah, how do you decide which one to use? I'm sorry, there is definitely no definite answer for that. Many packages have lots of different strengths of doing it. I think one way to choose one package over the other is try to go to the homepage of that particular package and see how actively it is being developed further. Okay, so every package is expected to maintain, so you can look at the last update date to that particular package, which means if there is an active community which is working on the particular package, then it is more likely that if you run into any bugs in that package or difficulties in using that particular package, the likelihood of getting a support for that particular package is higher. In fact, this problem is so true with any open source, right? Not just R. Even if you're a Java developer, you would know that there are so many Java packages out there. But just because a Java package is out there doesn't mean you can use it. You have to take care of using only those packages which have strong community support and so on. And if it so happens that you want to use it for a one-off usage, then it really doesn't matter. Okay. Any specific reason for using R or packages? Yeah. Is that the background that we are expecting for the data science program is that we are saying you don't need to have extensive programming experience. And programming with Python can be considered relatively slightly more advanced compared to R. Having said that, yes, you can do more advanced things with R as well. Okay, but R is more of a scripting language, so you can get up and running very quickly with R. But otherwise, the reason, I mean, you can also look at it the other way. You should note that we have included both R and Python, right? So although Python we have put it as a optional thing, the reason why we chose both R and Python is from an analytics perspective, these two seem to be emerging as the top two languages, open languages for analytics. Okay, so that is essentially the main reason. Okay. For reading XLSX files, I had to download the Excel Connect. That you are right. You need to use that Excel Connect package. Is there any function or package that comes in default with R? And no, there is nothing which comes with default. You have to use these packages for working or reading XLS files. Use joins like MySQL in R. Okay. You can use joins in MySQL using the merge function. And yeah, again, so the specific question I will read out for everybody's benefit. How can I use joins like MySQL in R? Like I wanted to use a join on cricket.test sheet and cricket.odi sheet to be able to say where player.odi not in player.test. I think this is naturally will come to you with an outer join, right? So you try to explore the merge function. In the merge function, you have the by clause, and there are additional parameters which says whether you want an inner join, left join, or a right join. Okay, so please explore that. I think I have covered this in my R session as part of the videos, and even probably as one of the Hangout sessions earlier. Okay. Okay. Can you clarify the detail with examples regarding type and class? Yeah, this is another example of how things have evolved over a period of time. We should also remember that R being open source, you can work with R at a pretty low level, especially if you are building your own complex packages. You would want very low level information about R, about many things inside R. So that is why they have many different functions which seemingly do a different thing, but one is considered to be a slightly lower level and another one is considered to be at a higher level. Okay, to see the simple difference, why don't you, if you are in front of R Studio, why don't you run the type of command and the class command on a data frame? Okay, so let me see if I can do that quickly for you. So type of my BDF is type of. What is the output that you're seeing, right? So class. So suppose we do it on the Bollywood data frame, right? So if I do it on the Bollywood data frame, the output of class BDF is data.frame. Okay, whereas the output of type of is list. Okay, on the same data frame. Okay, so what you can see here is the type of operator is a slightly low level operator. As I mentioned just a little while before, the data frame is nothing but a special list, actually, isn't it? So it is a list because why is it not a vector? Because if it's a vector, all of them have to be of the same type. So why is it not a matrix? Again, a matrix is matrix in R is referred to as arrays, right? So array are homogeneous data structures, whereas in a typical data frame, I can have one column which is numeric in nature, one column which is string in nature, right? So when I have such columns, when heterogeneous things, I need a list. So that is why the low-level implementation of a data frame is in the form of a list. So the type of gives you low-level information, whereas class is something that has been added to give you a slightly higher level information from a programmer's perspective. Okay, so that is essentially the difference between type and class. Right, same thing, right? Converting to factor using the factor function and using the as dot factor, right? For all practical, from all practical purpose, there is no difference between factor and as dot factor. Okay. Good. I think that is the pretty much the list of functions that I could address as part of this particular call. Good. I think that is pretty much from my side. Are there any other questions that I can try to take, or if there are any overflow questions, I will probably take it up with in the discussion forum. Okay.
Yes, Professor. There are
the moderator
questions.
online.
Yes. Hello.
Yeah, tell me.
Yeah. There have been like a list of questions that was asked during the live chat. So, what would be the better thing? Should I mail you or?
Hello.
Yeah, please.
Just what you do is just email it to me.
Mhm.
I will take it. I'll post it in the discussion forum.
Okay. But only one thing that professors wanted to know. Few students wanted to know what any recommended book on R.
Sure. The book I have. Can you go into mute? I think I'm hearing an echo. Okay. So I personally use 3 books as references, right? So there are excellent books. One is R in Action by Manning. And then the O'Reilly publication, the R Cookbook. Okay. The cookbook series from O'Reilly are very nice. So the R Cookbook actually gives you specific tasks and how do you do those specific tasks. And the range of tasks it covers is very nice. It covers nearly more than 100 specific tasks, right? Including how do you run a linear regression model? How do you do this? How do you do that? How do you apply a function? In fact, some of the examples that I used today's session, I have drawn it from the R Cookbook, right? How do you apply a function to every row? How do you apply a function to every column, etc., etc.? How do you read from Excel? How do you read from HTML pages, right? So everything, input, output, processing. So the R Cookbook is a great reference book. I think you should actually buy it and keep it with you. And R in Action is much more of a textbook, so which will go through all the nooks and corners of the R language. Yeah, that's these are the two books that are quite good. I have glanced through another book called R Data Analysis Using R, which is okay. And if you are a bit of a if you want a bit of humor thrown into your R learning, the Head First series generally uses lots of humor to teach R, to teach many things. So there are, it's a series of books, Head First for design patterns, Head First for Java, Head First for learning this. So there is a Head First book on R as well. So you can get hold of that. They contain a lot of funny examples, humor, and things like that. But I think R in Action and R Cookbook, these two are more than good. And see, in this particular program, we have not been emphasizing too much on using the R graphics packages for plotting and so on, because we are saying, no, you are better off learning Tableau for that purpose. But having said that, if you do want to go into the deeper usage of graphics in R, there is a cookbook on our graphics cookbook as well, which takes ggplot, for example, is an example of a package which we have been uh, introducing for the students. But for most, for as far as this program is concerned, we are saying you use Tableau. But if you want to get deep into it, our graphics cookbook is also there. Okay.
Thank you so much, Professor. And I guess we can close now. So
Okay.
hello, everyone. I guess the session was quite informative, and everyone was able to, you know, was able to clear out their queries on R and SQL. For those who haven't have sent out our queries, the professor will be mailing you. Will be mailed the question, and he'll be forwarding the answers accordingly. And do do not forget to click on the feedback button and give your feedback. And let's a happy Sunday, and we'll see you on 28th of Jan, when we'll be having another session with Professor RC on data warehousing. Okay, goodbye.
Thank you. See you next week.
Yes, sir.